Fault tree analysis, an essential RAMS technique. Fault tree analysis is a numerical technique based on probability theory, which will be discussed further in this course. It can provide us with indications of how likely an event is, either in terms of an average frequency or rate, or as a probability of occurrence. Designing fault trees helps us to approach failures in a systematic way. We translate our system knowledge into a logical representation of how a particular event might occur. We start every fault tree by defining an undesirable event, which we call the top event. For example, the loss of power to a railway control center would be highly undesirable. Such events are undesirable because they can lead to negative outcomes that may be disruptive or dangerous. In this case, we would see significant disruption to services. And that would ultimately lead to potentially serious crowding issues. But it is the loss of power event that we would examine through fault tree analysis, leaving the knock-on effects to be looked at with tools such as event tree analysis. We refer to our diagrams as trees because of the way that logical branches come together. In reality, fault trees tend to look like an upside-down tree, or perhaps more appropriately, the roots of a tree. Fault trees are a way to visibly show how basic events such as system failures and associated incidents can combine to cause a specified top event. Event trees can then be used to look at the subsequent effects and the final outcomes that might arise from that event occurring. You may also have come across the term bow tie diagram. This technique is in essence a direct implementation of fault trees and event trees used together. So let us now consider a very simple fault tree. At the top of this tree we have our undesirable event, referred to as our top event. In this case it is the loss of power to control center. The top event is the point at which we always start a fault tree, and it is from there that we have to look and ask, how do we get here? We call this a top-down approach. On our course, we will also discuss bottom-up approaches, such as those used in failure modes effects and criticality analysis. Fault trees contain logic gates, in this case an AND gate. Such a gate sets its condition on all of its input states being true. So in this case, if all forms of power supplying the control center must be failed at the same time to prevent any power being available for the control center. Primary power fails, secondary power fails, backup battery supply fails. Here we treat these failures as basic events. We never consider what causes a basic event, but we do need to know information about it, such as how often it is likely to occur. We could, of course, break these down further and look at lower level basic events that drive them, but when we do that, these are no longer basic events. They become intermediate events, which is another important part of telling a complete and readable story with our analysis.